Alright, comm radio. ELTs. You know, I suppose there's a lot that can be said about these. Their effectiveness has not been that great ever. They made a couple of major modifications, which we'll talk about in the system, but then sort of came back and realized that the cost would be extremely prohibitive to mandate it across the board. It sort of originally came out with this idea and said, "Hey, let's try it and let's do it." And by the time we get to the mandatory time, the cost will have come down. The cost didn't come down, and they then also weren't really able to prove that the newer type specifications worked all that much better. So, if it's not an airliner and it has more than one seat, you must have an ELT. Now, that's not to say that airliners don't have their own locating systems. They're very, very sophisticated locating systems, which is why it's extremely unusual that we had one disappear potentially out over Southeast Asia or the Indian Ocean. But it happened. And, remember we lost the Air France one out over the Atlantic Ocean in a fairly heavy traffic area, and it took us something like 2 years to find it. Someday maybe we'll find the Malaysia Air one that disappeared. So, emergency locator transmitter. Originally, it broadcast a warning carrier, and it was just like a warbling whoa, 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 on frequency, the AM band frequency, 121.5, or the military reciprocal of that, which is 243. It's just a doubling of it. And the problem was we never actually paid attention to it. Supposedly we had some satellites and some systems out there to pay attention to, but we never really did. In fact, it turned out that we were spending a whole lot of time watching the Russians, and the Russians spent a whole lot of time watching us. And it turns out their older technology was pretty good at picking up our ELTs. So it was pretty common for them to let us know that, particularly on the West Coast, that an ELT had gone off, and kind of approximately where it was. It was so bad that eventually we sort of shut down the monitor. Well, what we really did is we just stopped putting satellites back up into space to monitor the system along around 2009, because there was this mandate that we're going to go to this new system, except the mandate never really got imposed, and it's for good reason, I think. It's not all that great. It does work, but so the grandfather clause now exists. All those older airplanes can get away with having the 121.5 to fulfill the requirement that is required, even though it probably won't work. It'll work just fine, but nobody will be listening to it, unless you happen to crash short of near an airport, or on an airway that somebody typically flies over. Now, many airlines and other commercial operators regularly monitor 121, so they may actually hear it. If it happens, the accident happens to be in an area that they typically fly over. For that to happen, though, in all likelihood, the crashed airplane was going to be somebody that was already on an IFR or clearance or a flight plan, and so their incipient demise or whatever occurred will already be duly noted in the system, and there'll be people out there looking for them. So then the ELT will make it a little bit easier to find it, presuming it survives impact. So the newer broadcast, actually they went up to a much higher frequency, produces a much stronger, better signal, but it's not nearly as long range. It's more accurate, but it's not nearly as long range. And then as they sort of brought this in, it turns out that they said, well, let's put a little GPS unit in it, or feed it GPS data, and then we'll put that data stream on what we're transmitting outwards. Okay, well that's kind of cool. That makes sense. Meanwhile, though, however, we've still got airplanes listening to 121. So they then came back and said, well, let's also make sure it does at least a partial burst or short period burst on the 121-243 as well. So it's kind of doing them all. Rarely does it happen that an airplane lands on its tail cone. Most of the time they go in on their belly or the top or their nose. Rarely do they turn around and crash on their tail cone. So it's logical to put it back there, hoping it's more likely to survive. We basically use the same or similar technology to the seatbelt restraint system or the airbags used in your car. We use the G switch that's going to kick off somewhere around 5 to 6 Gs. Usually what it is it's a small little clip with a weight in it. When that thing hits 5 Gs, the weight releases, and when it releases, it pops out and the clip closes and connects the circuit and turns things on. Okay. And that'll be inside the unit. So the way that thing is mounted has to be such that if the plane does a rapid deceleration, it activates the trigger. Okay, it kicks it on. All right. It's been a long time since you haven't. I say often. Almost all earlier 121.5 units contain, and all of the new 406, because it's part of the standard, include a remote antenna with a little dongle that you can attach. And the way they're mounted, they're not hard mounted. There's a bracket system that's mounted in the airplane that you can then unclamp, pull the unit out, take it with you if you need to depart the airplane. So it will continue to broadcast your location. Some of them actually also have a little microphone jack that you can take the microphone and stick it in there. I don't know that you're allowed to transmit, but I think they will receive information on them. I don't remember, there was a rule around that. So, also because they went off all the time, a hard landing can do it. Okay, they went off all the time, a hard landing can do it. You get in, you pull off. Nobody ever listens to 121.5 before shutdown. So get out of the airplane, lock it up, go have a dinner. Right? This thing's going beep, beep, beep. About an hour later, the Russians call and say, man, we're really tired of hearing this thing. There it is over Bend Airport. Go turn it off. Right? So I think it's a pretty good thing because in a lot of regions where they have Civil Air Patrol, which is the young kids and young adults organization, it's a perfect thing for them to go out with a little Yagi antenna, slightly tuned off of 121.5, and they can just sort of go around like that and then go walk towards that and then that one and then, oh, it's your airplane. Okay. Then, of course, they find who the owner is, and the owner says, well, I don't have that airplane. That's, of course, that's you in the restaurant line for your teeth. So what they required is a little panel mount thing that you can see from sitting in the pilot's position that has a little light going flash, 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 telling you that it's on. It also must have a way of shutting it off. And they usually include a way of doing an activation test from there as well. This thing will not be connected to the aircraft's electrical system. It operates completely independent of it. It's got its own batteries. So there it shows the little panel mount. There's a little panel mount in the pointer, I think that's the pointer one. A couple little I actually think the two yellow ones are the 406 units. And there, it used to be the little lower cost ones were in the neighborhood of about $300 to $400, And I think the 406s are all in, in the $1,000 range, somewhere in there. They're not cheap. When they originally came out, they were like $4,000. So here's where you start getting into Part 125, or Part 121 operators. Okay, flight data recorder that will have a transmitting beacon that can operate, and it's actually powerful enough to operate underwater, and it will hopefully record a whole bunch of data. Anyways, and most airliners, they will have a data recorder and a voice recorder both in either end of the airplane, so that they can, if one end gets destroyed, they can at least capture some information from the other end. This particular one, so you see that this mounted up on top there, that's an acoustic beacon. So if this gets below a certain amount underwater, it gets crushed enough to where it starts transmitting an underwater beacon to hopefully help find. But trying to transmit through water, your range isn't going to be very good. It's only going to be a few miles. Okay, so any airliner that goes in over water, of course, if it sinks deep, it's going to be pretty hard to hear that thing. Again, another voice data recorder. This is one of the ones up forward, and this is actually just a straight beacon. So if this thing gets thrown out of the airplane and goes into the water, it'll theoretically, if the airplane gets broken up, that will get launched out of the airplane, and it's designed to float and act as a beacon to give you some information about where the crash site is. The Indy 11 that crashed had several of these on board, which is sort of puzzling as to why. If those things are powerful enough, they should have easily been picked up by satellites in the area. Who knows? So you guys have to maintain them. If they in fact have been operated for more than 1 hour, or if they have been, or if the operation caused more than 50% of their use to occur, or if they have had a shelf life of more than 50% of the batteries must be replaced. This can be a little difficult to tell, because some batteries, particularly if it uses the D-cell type batteries, have no expiration date on them. Other batteries, they have expiration date like 2028. It's like, well, oh, wow, okay, that's a long time. So it uses no power if the thing is in if the G switch hasn't been activated or the test switch hasn't been activated. So when you say 1 hour of use, you actually need to be very clear about that. So if this thing can actually last all the way out to 2028 or half of the useful life, you know, every time you test it each year, could it start adding up to close to an hour? Oh, I don't know. The truth is, the test for the older ELTs, it takes less than a second. Tune on the frequency with a little handheld, the hangar door is closed. It's just, whoop, whoop, whoop. I mean, it's very, very quickly. You can tell it's working. It's pretty loud if the two radios are close to each other. You will then test to make sure that it's the bracket hasn't come loose, the bracket hasn't been distorted or damaged, there's no corrosion going on. Usually it's a steel bracket bolted to an aluminum structure. Supposedly you're supposed to keep a logbook entry for separate logbook entry for the battery expiration date. This is another one of those sort of quasi weird ones, because the logbook entry really isn't defined. What's a maintenance record entry? I mean, theoretically, I could take a picture of the batteries and that would constitute information. So again, this one's a little weird. I would say you know, of the 15 varieties that are out there, a small percentage of them, maybe 3 or 4, actually use D cells. The rest of them have this really fancy different kinds of battery pack that are very specialized. What it really is a bunch of D cells soldered together, taped up in a little package, and then they charge you, you know, $150 for $4 worth of D cells, right? Because they can. In any event, you're probably going to have to take the thing apart, some screws, an O-ring, something that makes it watertight to get the batteries in and out. Put them back in, do some maintenance record entries, and sort of every annual or every year you're going to have to get in there and do something with respect to the ELT. So, yeah, actually, I think that's because that's the pointer. I've actually got one of those in my 2-place airplane. The 1-place airplane, I don't have one because I don't need one. And I know how well the system works. I think this is the ACK version here. So you'll note there's a BNC antenna connector, and this is a little Molex type connector that's just like a phone jack. Okay, here they spliced it into regular wire, and then it goes up to the cockpit panel. This one I'm not quite sure, but again, it goes up to, that's the little panel wire that goes up to the little instrument panel, and then that again is your antenna connection. And then a lot of times, yeah, right here, see this little bracket? That's the dongle antenna. So after you crash, get out of the airplane, undo the clamp, pull that out, pull a little antenna out, undo that lead, and pop the antenna on there, and then call somebody who cares. Again, I don't remember. I know you can plug a mic in some of them. I just don't remember if it lets you transmit. I think it may only let you receive. Or it may be the other way around. You can only, it's not a transceiver. So here's one. It's in a rag and tube airplane. I don't know if they put a bunch of silver dope on the fabric. That's going to shield it quite a bit. So forward of the airplane here, this is sort of barely in the tail cone. Nice little bracket here, and then they've mounted the antenna right here. Okay, so it's facing forward. That's good. Crash, bang, tail sticking up. The antenna's in a nice sort of foilized metal tube, so it's not transmitting anywhere. Right? Okay. Okay, fine. And of course, if the plane goes crash, boom, now not only is the antenna in a metal tube, not transmitting anywhere, but it's now laying on its side, so it's not vertically polarized, which it needs to be vertically polarized for anybody to be able to receive it more than 10 feet away. So I would question the validity of that installation, which is kind of why I threw it out there. There is another one. Yeah, that is the ACK version. Again, similarly, note the arrow orientation saying that's the end of the airplane that's most likely to crash. This particular one, what do we see? Antenna cable here. I'm not entirely sure what that's about. This is your modular connector. That's just like the little phone connector. That will connect to the little instrument panel that has the little light and the little switch. Inside here, they've got a red button over it, but there'll be a little switch in there that allows you to go off, on, which means it's transmitting, or in between, which means it's active, but you have to activate the G switch to get it to go into transmit. So off means it ain't going to do anything for you. On means it's transmitting, turn it back off. Oh, there's another one that's, the unit is in a very nice little metal container, but fortunately, well, we don't really know where the antenna is. And again, I'm just, it looks like the rear inspection on a 172, if I were a guessing person. So these are typically just a very thin rod. Some of the bigger airplanes, it'll be a blade, but often it's just a little thin wire. You'd have a thin little wire and then a curly Q, and then the wire goes up, and they might have a very small little Corona ball on the end of it. And very commonly, that's the type they use. Typically top rear, again, 30, 36 inches away from anyone else. I have to say that part of it's sort of meh. The bottom line is you go, whack, boom. Well, if you can transmit on your comm antenna, I don't care where that antenna is. Well, right? If I really need that one, it's not coming on until after I've crashed and the comm antenna isn't even attached to anything. Okay, so it doesn't really matter that it's 30 inches away. At that point, it's going beep, 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 beep. Eventually, I come to, if I'm still alive, right? Then I go dig that thing out, and it doesn't matter where the antenna is attached, because I'm going to put the little remote antenna on it. So, however, when you go read the directions, they say stuff like this. Again, anytime you mount an antenna to a ground plane, you must have a little bit of paint removed so that it makes a good metal-to-metal connection. That's true of these as well. And again, if it's a composite airplane, carbon fiber, fabric, wood, etc., you're going to have to put some copper tape in there or something to make a ground plane. Yeah, so there's an example of one. At least this individual did a reasonable job of mounting it on the vertical. It's in wood, so that's going to interfere with transmission somewhat. But it's still, at least it's vertical. It's in there a little bit. Got a nice little mount, room for the BNC to come in there, and then he made a very nice little ground plane using copper tape. So the antenna lead will typically be a coaxial cable. The copper shielding one that you saw in there a couple of times, that's RG400. RG400 is actually a fairly good choice, but you want to keep it very short because the tuning resistance for RG400, it's actually it's great for the transponder frequencies. It's a little bit high for AM band aviation frequencies like 121, but if the run is fairly short, it's not going to degrade the signal too much. Anytime your coaxial is run, it should always be left a little bit loose, supported enough to where it doesn't chafe or bounce things around. But you never want it really, rigidly held tight. And then there again, the remote activation, manual activation switch, and indicating light. Those actually, what I find more often is they use the little module connectors on them and put a really long cable in there. But it's so lightweight, hook it up to the panel, route the wire all the way back to the ELT, and any left over, just bundle it up, tie wrap it, and plug it in. Don't bother cutting it in the module off and trying to put a new end on it. So in some of the 406 ones, they actually have the ability to attach to an oral device, some kind of enunciator that says it's on. As well, they may have a coaxial data line coming from any GPS producing device, like the Garmin 430 or whatever. They may have a data line coming over that, feeding the most accurate GPS data to the ELT. So you wouldn't see that on the earlier 121s, but the newer 406 standards, that may be happening.
Why do you see so many ELT antennas on the belly of aircraft? I mean, you've never seen them?
Oh, I've seen it. They're all over the place.
Yeah.
Funny little wires sticking out. See them all the time. It's like why? It's nuts. It's most likely the first thing to get wiped off.
Yeah.
After the gear get wiped off, then the LT antenna. I know. I've seen it a bunch of times.
On certified aircraft, quite a bit too, you know.
I know. I mean, they do it because it's unsightly and it doesn't get bumped or banged, et cetera, but, you see people do interesting things. Okay, so let's get back to talking a little bit more about, the, frequencies in navigation and kind of how this navigation stuff works. So within all the navigation range, so your localizer, VOR system, that, like we said, goes from 108 all the way up to 117.9. The lower portion, we're going to divide part of it out for use in the ILS system, the instrument landing system, for horizontal position data. Okay, so all of your odds from 1081 to 111.95, we're going to use those for the localizer, and then all of the evens from 108 to 111.9 and everything above 112 we're going to use for VORs. Okay, so then this group of localizer frequencies will each get a unique paired glide slope frequency. We don't ever need to know what that is. That's just programmed into the radio. So when I tune to 111.95, I will have also tuned the glide slope to its unique paired frequency. Okay? They do rely on line of sight navigation, and it is rigorous. Utterly, absolutely rigorous. If I go out to that end of the airport and park my Volkswagen 35 feet away from the antenna, that airport is no longer landable. The ILS system is not usable. Okay? Without a whole bunch of significant testing to make sure that piece of metal, even though it's kind of far away, right, it's decertified. You don't see this too often, but most bigger airports, they put all kinds of signs and all kinds of stuff. Don't come here. Don't come here with your body. Don't come here with anything. Now, some of the antenna arrays are putting out enough radiation, I wouldn't want to be physically near me. The only place you sort of see that happening is like out at Oshkosh. We're all over the place out there. Well, during the period of the event, the ILS isn't in use with some very specific special exceptions. When some of the big hardware is coming in, and even then they're told you can use it on a VFR arrival, visual flight rules arrival, but we were not going to let you use it under instrument conditions, true meteorological conditions, because there's just too much equipment nearby that can cause the signals to distort and do weird things. So they're pretty sensitive. We're going to try and make the antenna, because the whole goal of this for the ILS system is to be pointed at the runway, get myself around to where I'm now pointed at the runway. I'm going to come around here, and okay, now I'm pointed at the runway. So I want it to be able to receive from the very front of the aircraft. I might be a little bit of a slip, but I'm going to need it to be pointed kind of at the front of the aircraft. So I'm going to want my antennas mounted either up on the vertical stab, out in the nose, somewhere towards the center of the airplane. Because if I put it out on a wingtip, that means I'm going to land one wingtip, you know, right? Okay. Typically, I don't know if there's an example where they aren't dipole, but they're horizontally polarized, and everyone I've seen is a dipole antenna. The functionality of the localizer transmitter and the VOR transmitter are entirely different. They don't operate the same way at all. What you see on your display is pretty much the same. The only difference is it's the distance of needle travel is twice as sensitive on the ILS or on the localizer. I think I'm saying that right. Every dot equals twice as much distance on the localizer as it does on the VOR. So you get a much greater degree of sensitivity. So because they're very different, we have to talk about both systems. So yeah, there's the VOR antenna. I don't know where that is. It looks like a pretty mountain field with rabbits and squirrels. So this guy's going to have a master antenna and a rotating antenna. It's very directional. The master antenna is going to be omnidirectional, and a rotating antenna is going to be extremely directional, as into accuracy of a 1 degree. So what we're going to do, in this case, I show a nav comm there, the 155. Not going to worry about the comm side, but the nav side's over here. Same idea, standby frequency we tune, hit the flip flop, kick it over to the active. That's then now providing data to here. Okay, we could have made a nice big compass that you could spin around in the direction of an airplane and have a line pointing to whatever heading is at any one time. The problem is to fit that in a small plan form, you wouldn't have very good sensitivity, very good resolution. You wouldn't be able to see it that accurately. So what we really have done is we've said, here's a needle that could go all the way around, but instead we're going to pivot it up here and have 1 degree tick marks each direction. And that's only going to give me a few degrees, but I can rotate this wheel to get the rest of the gross information. Okay, so we're saying 5 degrees either way. So as long as I bring this wheel around in, I'm going to have, I can pick a line that's coming off of that thing, know where that is located on the planet, and then get a very specific heading either to or from. So now some things are going to be a little bit unusual here. First off, if I'm going to draw a line from a point, I've got a reciprocal line going out that way. The airplane could be facing or facing away from, okay, or the other side of it. So there's a little bit of room for confusion here in terms of how to interpret the data, which the pilot's got to spend a little bit of time figuring that out. So we're going to give the pilot some information whether or not they're tuned to or from. And if I was tuned to and the needle was in the middle and I'm set to here, what I could do, and that flag would be off, is I could spin the OBS wheel all the way around to where the 6 was up to here, and then the from flag would be active. Okay? And then glide slope information is going to be tick marks this direction, based on that needle. So this is kind of, and this GIF actually does a reasonably good job of describing how it works. So the VOR navigator is going to go blip, 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 blip with a master omnidirectional pulse that goes out. Blip, and you can see it briefly. Blip, blip, blip. Okay, it's just going along, flipping out there. Right? It's then going to have a very directional one that's spinning around pretty fast. So every 30 seconds for the master beep, and then the spinning one is also spinning around 30 times a second. So the receiver says, here's the blip, 1, 2, 3, 4, 5, 6, 360. 1, 2, 3, 4, 5, 6, all the way up to 360. 1, 2, 3, 4, all the way up to 360. And wherever the directional one gets loudest, it knows where it is relative to the blip. Whenever the master blip hits, that beacon is always right pointed at magnetic north. Okay? So now I go blip, and I'm 105. Okay? Whatever the units are 105 360ths of a 30th of a second. It's happening pretty fast. My antenna out here says, oh yeah, I got it. Okay? So now it knows I'm on this radial, right? Now, depending on which way the plane's pointing, it doesn't know which way the plane is pointed. It has no way of knowing which way the plane is pointed. That's why you have that OBS wheel, and you're going to have to spin that around. So if you're heading towards it, you want it set to the 105. If I was heading away from it, I would want it set from the 105 if I'm trying to track the radial. Okay. Meanwhile, we're gonna call this the 105-degree radial, which makes sense if 90 is straight out here, 15 degrees, okay, right? Of course, everything needs to be offset because we know that magnetic north isn't the same as true north, unless we happen to be on Greenwich, which case all good. So does that sort of help explain how that works? It's a little confusing, but it's just a very directional going blip, and all I have to do is be able to count quickly. Now that's pretty fast because it's doing this cycle every 30th of a second. But that's okay. Radios can do that stuff really, really fast. Okay, so it just counts 360 increments.
How far out are you when you pick that up?
It depends on what angle you're at. So the other thing we're going to do is we're not going to point it out here because unless you're like me, you're not going to be that low. So we're going to point its strength. We're going to focus the antenna to be sort of pointed up this way. So if I'm at 38,000 feet, I might be 250, 300 miles out. Okay. If I'm at, only 2,000 or 3,000 feet above the VOR, I may not pick it up, I may, 50 miles, 40 miles. And of course, it also depends on how good my antenna system is set up. But typically, again, short range, we're looking for some expectation of about 200 miles. And anything outside of that, you're probably not going to get it. I can say, like, I have no problem picking up the Julian VOR anywhere from about 80 to 100 miles, anywhere around it. The Julian VOR happens to be convenient because it's way up on the top of this big mountain, so it gets pretty good broadcasting range. There's one in Mission Bay. I don't know if you guys have seen that little island in Mission Bay. It's got one of those. There's another one called Pogie, which is just about a mile north of Brownfield. Again, on the mesa. It's not that strong. There's one, if you take 5 north of Oceanside, you're kind of right along the coast. You pass Santa Margarita Lagoon, and they have the trains, coastal train stations right there. The train depot. It's sort of their yard is right there. Well, just on the ocean side, there's one of the VOR antennas there. I think I covered most of them in this area. Okay. So yeah, it's just that time difference. So the unit knows the master pulse happens when the directional unit is right at north, and whatever number of microseconds it takes to come back around, that blip gets to be the strongest value, it then says that's how many degrees, or that's the radial we're currently on from that location. Okay? Then you, the pilot, have to interpret, depending on which way the airplane is facing, whether you want it to read from or to. Now, what does that mean to you as the pilot? Let's say I've got it backwards. What does that mean? All it means is the data display is going to be backwards. So theoretically, I've got a line. As I come off, okay, I want to steer back to the line, right? As I come off, I want to steer back to the line. Well, what that means is it's now going to be backwards. So as I go this way, it's going to go the wrong direction. So I'm going to have to get that right in my brain and get the needle to behave correctly. But after you've used the system for a while, it's actually not that difficult to sort it out and make it work. Not nearly as easy as GPS, because GPS just shows your map right there. Okay? And after about 8 to 9 feet of movement, it'll even point the airplane in what direction it thinks you're going. All right, so there shows a couple of different displays. So in this case, they're showing, well, first off, they might have a big flag that comes down and says, no joy, bad information, don't pay attention to me, you're going to die. If everything's working, the flag's gone. In this particular case, we're saying we're headed to on that radial, but we're a little bit off to one side. Okay? So if I wanted to get back to get this centered, I'd need to steer a little bit this direction to come back to it. If I'm actually on the from condition, I'd actually want to steer away from it to get it to come back. That's what the backwardsness is. This guy here is pretty cool. What we did here is we said, okay, this is the line, the lubber line that I want to be following. Okay, and I can be off one way or another in terms of horizontal position. However, we're going to orient everything to a magnetic compass. This is called the HSI, or horizontal situation indicator. So this does a pretty good job of showing where the plane is relative to magnetic, and then how far off you are either way from the expected line that you thought that you want to be on. So in this particular case, this is the direction the plane's heading, and I'm way off to this side, but that means that I should now be coming towards that line. Okay, as long as I stay on this heading, this line will get closer and closer, and then when it gets to there, what I'm going to want to do is rotate the airplane so that the green comes up to here, and then I stay on that line. Okay, so horizontal situation indicator, very, very nice. That display and the unit is going to cost you about 12 to 15 grand. Okay, this guy here is going to be fed data from your Garmin 430 or whatever. It's going to cost you $1,500 plus installation and all the rest. And somewhere in there. Of course, you don't care what it costs because 12 grand is pretty nice when you put a 15% markup on it and pay your rent. Okay. All right. So this is out of the pilot's manual. This is sort of showing what happens when you're, in this particular case, this plane is over here in the from, so as he flies towards the needle, it'll come back to there. Here, same thing, as he flies towards the needle, he'll come back to there. On the 2 condition, again, the needle's off to this side, so if he flies towards the needle, or vice versa, towards the needle. If this was backwards and the flag was facing the other direction, then the needle would operate the opposite direction. Okay? That makes sense. And this presumes that this is the 03, we got 210, yeah, 030 radial right there. And as the plane crosses the apex here, either way, as it crosses, if it's set correctly, the flag will flip from to from as it goes across, and you're staying on that same radial heading. If you went and turned around and decided to go back, you'd want to take the OBS and swing it around to where the 2-1 is up and the 3 is down.
What's with the Morse code identifier? Why did they?
It's been around. So every one of these transmitters, the VOR transmitters, VOR, not ILS, actually ILS does it too. They have an identifier that's not audio, although there are a few that you can talk to flight service through them. The idea is, let's say you tuned to the wrong frequency and didn't realize it. Okay, or there's something else going on that you missed. Theoretically, you can push on your audio panel, listen to the nav audio, and you'll hear the beep, 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 beep. They use Morse code because that's what was available then. And they've made no need to change it. You'd have to buy a whole bunch of hardware and change every VOR out there. So that's going to cost money. And you're pretty sure DOT isn't going to want to spend any money on it. Especially when they're spending billions of dollars on putting GPS satellites out there. Does that answer your question?
Yeah, my unit just has a flag, so if it comes up with the identifier visually, it's good. But the older ones, the Morse code was really a pain to remember.
Oh yeah,
especially if you're busy on an approach.
I get you, I hear you. Yep, but that's what they had back then. See, back then, real pilots were real pilots. But they weren't, they just didn't live long. Okay, so, yeah, again, much higher frequency range, 329 up to 335 for your glide slope. Each one of these are uniquely paired with the individual localizer frequencies. So you don't have to tune that. That tuner exists in the nav radio. Okay, but the pairing is done automatically. Also, line of sight navigation. The antenna again needs to be located with the transmitter with the least amount of interference, landing gear, exhaust pipes, prop, etc. They're pretty strong transmitters, though. Both the localizer and the glide slope are pretty strong transmitters. They just transmit in a very narrow focused beam. So there usually aren't too many things out there. Also dipole, because now what we're trying to do is sense data this direction. Okay, so it's positioned that way. So there's a couple examples of, one's going to sort of sit on a flat surface. That one can sit like that or down like that, depending on which type it is. So what they do is actually remarkably simple. On the frequency, what they do is they transmit two lobes of tone. Very narrow prescribed lobes. 90 hertz one way, 150 hertz this way, with a little bit of overlap. And then they're going, oh. So when they get right about the middle, and they've got it tuned, they get it pretty accurate. So the airplane's going to be out here. You're going to have the transmitter way out on this end of the runway, give you a little bit of distance, and transmitting these two lobes out, and the unit's going to be tuned into whatever that frequency is and trying to get the magnitude of both frequencies to be exactly the same. That tells it it's in the middle. Okay, that's pretty simple. And of course, the closer you get, the tighter it's going to get, right? It also has some what's called the back lobes that are much weaker, but they will provide back course information. Similarly, it's backwards. But what that does for you is if you miss approach and you need to carry on, you'll get some back course information. Your needle will operate backwards, but enough to where you can get back out, climb out, get back into the airspace system, and either get vectored around or head back to the very beginning of the approach and work and try it again. So the glide slope, we're going to do the same thing, just on a completely different frequency. So we're going to have two lobes that are now rotated this way, okay? And we're really going to actually have a ground plane and the aerial right there, but the antenna is going to see this as the center point of its focus. We're going to send the low frequency right along the ground, the high frequency lobe upwards, and then this glide slope, whatever it is for that particular airport, they're not all the same. My guess is all the flat airports out there with all the flat land around them, they're the same. But many airports around here in California, you've got all kinds of different things happening, like going into Lindbergh, okay, got all the hills, right in and around there. So things are adjusted accordingly for maybe a slightly steeper glide slope. Okay, if I take and put my little Volkswagen out over here, that's going to really annoy everybody because one of these signals might shift up or down. You're going to change or distort that lobe a little bit. So now my plane might be coming in down here, down there, and oops, I hit the parking structure in there. My little, okay, oops. It's funny, I used to read SDRs, all the service difficulty reports all the time. And every once in a while, one would come by about a navigational system, and it was usually some idiot parked the truck, a van, somebody who was out on the airport looking around, integrate. And it was like, okay, they shut down San Francisco International for an hour because, yeah, remarkable. They focus this, they're so intense about this. After Oshkosh is done, nobody gets anywhere near the antenna arrays. I'm usually pretty good about shooting anybody that goes anywhere near there. Nobody gets anywhere near there. But all the equipment's pulled out, everything's brought back to sterile, and they go do a recertification of it, even though nobody's actually been out there touching it or anything. Just the fact that stuff's been in and around there, they're like, yeah, no, let's go recheck it. So now this is what the pilot gets to see. So here's a whole bunch of information, and there's several different ways the pilot can do depending on the approach plate. So they're going to say either use your altimeter, use the glide slope, use all of the above. So then there's going to be, and it gives different distances between outer marker, middle marker, inner marker. Here might be decision heights for various different conditions. Okay, if you don't see the airport by here, based on the type of approach you're doing, you got to get out of here. This one you're allowed to go a little bit further. This is Category 2 ILS. I think Category 3 is the one that if you have the equipment on board, you can go all the way down to touching the mains on the ground without being able to see the runway. There's only a few. I know LAX. I don't remember if San Francisco is or not. I know LAX is Category 3, but that means that both the airport and the airplane have to be able to do that. Now, I don't know about you. I landed a lot of times in an airplane. There is no way, in any way, shape, or form, I'm going to land in an airplane where I'm seeing nothing but milk bottle out the windows. And you don't see the center line on the runway till the nose gear comes down. I'm just not going to do that. Don't want to be in the airplane that's doing that. I don't care if it's got GPS or magic, Harry Potter magic. Okay? I don't want to do it. All right, let's stop here. We can talk about GPS next week.